Okay, this is lecture number 2 of power electronics. Okay, starting with the first page. This page is basically the last page of lecture number 1, page number 11 of lecture number 1. This page basically has triac and diac explanation on this. Only the first page is handwritten, and the remaining lecture is all typed. Okay, so starting with this triac and diac. Basically, what is a triac and what is a diac? What are their symbols and how where they are used? Triac is a. I can amplify it a little bit. Okay. Triac is a multi-layered device that is electrically the same as two thyristors connected in inverse parallel on the same wafer. Basically, this is a thyristor. You can see there are two thyristors connected in inverse parallel. Means this side has anode of one thyristor and cathode of one thyristor. Similarly, and this other side has anode of one thyristor and cathode of other thyristor. And then we have this gate terminal. So two thyristors connected in inverse parallel on same wafer. And what happens then? We cannot say this terminal as either as anode or a cathode, or neither we can say this terminal as an anode or a cathode. What we will call them, we will call it a terminal 2 or terminal 1. Some books call it MT1 or MT2. So we will call it, this is terminal 1 and this is terminal 2, and the third terminal is the gate. So this device is called a thyristor. You can see their VI characteristics here, and this one is their wafer. So how this triac turns on? Since the term cathode and this is written here, since the term cathode and anode have no real meaning for triacs, hence terminal 1 and terminal 2 are used. So we will call it terminal as terminal 1 and terminal 2. Okay, how this triac turns on? The gate signal is applied between terminal 1 and gate. The gate signal is applied between terminal 1 and gate, just like in thyristor. In thyristor, we apply the gate signal between gate and cathode. Here, the gate signal is applied between terminal 1 and gate. The triac can be turned on by injecting either a positive or negative current. Uh, how this triac is different from a thyristor? In thyristor, we basically provide a positive gate pulse at the gate terminal, which turns the thyristor on, but a triac can be turned on either by a positive pulse or a negative pulse. Then here, there are some conditions here. It is, however, more sensitive when a positive gate current is used with terminal T2 in positive at positive potential. So where terminal T2 is at positive potential and a positive gate current is used, it is in more sensitive condition, which is called forward conduction. And similarly, if a negative gate current is used with terminal T1 at positive potential, this is called reverse conduction. So this is another sensitive condition. The least sensitive condition is when a positive gate current is applied with terminal T1 at positive potential. This is the least sensitive condition of a triac. Now, what is a diac? Diac is basically essentially a gateless triac. This is, you can see, this is the symbol of a diac. Diac, you can see similarly two thyristors in inverse parallel, but this diagram does not have a gate. It is a gateless triac. So we can say a gateless triac is a diac, and where it is used mainly used in trigger circuits. And how it is turned, how it gets turned on. It turns on with a very low voltage in both forward and reverse direction. It can turn on either by uh, putting terminal 1 at higher potential than terminal 2, or terminal 2 at higher potential than terminal 1. Very small voltage can bring this diac in conduction state. forward or reverse direction. Okay, you can cover this topic up to here only, trigger circuits. The last paragraph is not required because there is a diagram missing here. So you can say that a main application of DIAC is in trigger circuits. So up to here you can cover this topic. Okay, this is DIAC and TRIAC. Now we will cover some other topics. Gate on-off thyristor. Gate on-off thyristor is a type of thyristor. In last lecture we covered 11 types of thyristors. So gate on-off thyristor is one of those types. What is a gate on-off thyristor? You can say a gate on-off thyristor is a PNPN device in which it can be turned on just like a ordinary SCR by a positive gate current. Means like a ordinary SCR turns on when a positive gate current is provided between its gate and cathode, but in a gate turn-off thyristor, it turns off if a negative pulse is applied between at its gate between gate and cathode. So with positive pulse at gate, it turns on, and with negative pulse at gate, it turns off. So this is a symbol of a GTO or gate turn-off thyristor. This double arrow shows that positive pulse turns it on and negative pulse turns it off. Okay. So this terminal is anode, this is cathode, and it is a gate. And this double line shows that it is a gate turn-off thyristor. Ordinary SCR or ordinary thyristor has a single line showing this gate, but a gate turn-off thyristor has a double line which shows that it can be turned off by a negative pulse at the gate. Okay, some definitions here. What is line commutation and what is force commutation? A conducting thyristor can be turned off, making the potential of the anode equal or less than cathode potential. The line commutated thyristors are turned off due to the sinusoidal nature of the input voltage. So basically, how a thyristor is turned on? Thyristor is turned on when anode is at higher potential than cathode and a gate pulse is provided. So if we reverse this condition, means if we make the anode voltage equal or less than the cathode potential, then it will turn off. So a line commutation basically happens due to sinusoidal nature of the input voltage. I can show you the sinusoidal wave with the lecture number 1, a waveform in lecture number 1. Let me change the slide here. Okay, this is a waveform. This is a waveform of a sinusoidal waveform at the input. Basically, you can see this circuit here. This circuit has in sinusoidal input and a thyristor and a resistor here. And this waveform basically showing the voltage at the resistor or output voltage of this circuit. So you can see that in the positive cycle of this input, the anode will be at higher potential or positive potential than cathode. As soon as this waveform enters in the negative cycle, the voltage polarity will be reversed, or anode will be at lower potential or negative potential with respect to cathode. So due to this nature of sinusoidal waveform, the thyristor will automatically turn off. So this is called line commutation. Okay, now coming back to our lecture number 2. This is line commutation. Okay, force commutation. What is force commutation? Force commutation thyristors are turned off by extra circuit called a commutation circuitry. We will use some external circuit to turn off a thyristor. So in force commutation, there is no natural commutation like the sine waveform. In force commutation, we will use some external circuitry specially designed to turn a thyristor off. Okay, what are the 5 turn-on method of SCR? These are the 5 methods which are used to turn on an SCR or thyristor. Forward voltage triggering, gate triggering, dV by dt, rate of change of potential triggering, or light triggering or temperature triggering. These are the 5 methods which are used to turn a thyristor on. Okay. Some definitions of latching current and holding current we have already defined in last lecture. I'm just again discussing it because in the maybe some clear form it is written. The latching current may be defined as the minimum value of anode current which it must attain during the on process to maintain conduction even if the gate signal is removed. So the minimum amount of anode current which a thyristor has to maintain even if the gate current is removed, gate signal is removed, is called latching current, and holding current is basically the minimum value of anode current below which the SCR will turn off. The holding current is slightly less than latching current. Thyristor protection. This lecture is mostly focused on thyristor only. I already told you that power electronic devices, there are multiple power electronic devices like power diodes, power transistors, thyristors, and other devices, IGBTs and power MOSFETs. But we will mainly focus on thyristors because our next topics basically use thyristors in converters, or thyristors and diodes are mostly used in converters and some power transistors also. So thyristor protection, thyristor has to be protected. There are three types of protection for thyristor. One is over voltage protection. In over voltage protection, there are two types of protection. One is internal over voltage and other is external over voltage. And next one is over current protection. This is over current protection. And the next one is heat protection. So a thyristor has to be protected for three conditions: over voltage, over current, and heat protection. So what is an internal over voltage? It is due to the operating condition of SCR. When a thyristor or SCR is conducting, its internal operation can cause some over voltage. So internal over voltage is basically experienced during the internal mechanism of a SCR. So external over voltage, what is external over voltage? There are some external elements involved in external over voltage. This is due to external supply and load condition uh, other than its internal mechanism. This is because interruption of current flow in an inductive circuit or lightning strikes uh, on the lines feeding the thyristor system. So thyristor has to be protected for external voltage. Okay, how thyristor can be protected against external over voltage? We can use RC circuits or non-linear resistors called voltage clamping device. These waveform basically show you some over voltage and over current happening in a thyristor. This time versus current, and at fault condition there is suddenly a large amount of current passing through a thyristor. And this is the melting and arcing of, this is a fault condition of a thyristor, melting time and arcing time. Okay, voltage clamping device. What is a voltage clamping device? Is a non-linear resistor. It is connected between cathode and anode of SCR. The resistance of voltage clamping device decreases with increasing voltage. So basically, a voltage clamping device is connected between cathode and anode of a SCR. So as soon as there is some high voltage happening in a thyristor, the resistance of this voltage damping device decreases. So it basically supplies a short circuit between anode and cathode, and this short circuit basically saves the thyristor from over voltage. So this is a voltage clamping device. There are three types of voltage clamping devices: selenium diodes, metal oxide varistors, or avalanche diodes, suppressors. These are the three types of voltage clamping devices. Achha. Over current protection, what is over current protection? Just like over voltage protection, thyristor has to be saved for excess of current passing through its uh, two terminals. So long duration operation of SCR during over current causes: number one, junction temperature of SCR to rise above the rated value, causing permanent damage to the device. SCR is protected from overcurrent using circuit breakers and fast acting fuses. These two are basically the devices which are used for overcurrent protection: circuit breakers and fast acting fuses. Circuit breaker is long tripping, has long tripping time. You may have seen the circuit breakers in your normal household appliances. A circuit breaker basically has a switch tripping time, and basically as soon as there is overcurrent, current over the safe value passes through a circuit, it basically trips and disconnects the supply to the thyristor. So circuit breaker is one of the methods for overcurrent protection, and second one is this crowbar thyristor. This crowbar thyristor is basically a safety mechanism for power converters. In this diagram, you can see that this crowbar thyristor has its gate connected to this surge current register. So as soon as there is some overcurrent passes through, this thyristor turns on and the supply basically is reduced. Supply is basically uh, comes through this crowbar thyristor, and this converter is cut off from the power. So this crowbar thyristor is a safety mechanism against overcurrent protection. As soon as there is overcurrent or dangerous current passing through this circuit, this gate trigger circuit will sense that current and it will turn on this thyristor, and your circuit will be reduced to this side only, and this crowbar thyristor will turn on and current will pass through it, and this power converter will turn off and get safe from overcurrent protection. Okay, what is heat protection? Heat protection, you can see that most electrical devices or electronic devices get heated when they are in on conditions. So just like other electronic devices, thyristor also gets heats up when it is in on state and working for some time. So uh, we have to use some heat sinks. These are metallic pin type heat sink, and this is SCR hockey puck on power. These are two types of heat sinks which are used. This metal basically absorbs the heat of the thyristor, and this is directly mounted on top of a thyristor. Okay, what is power MOSFET? We will not discuss power MOSFET in detail. Power MOSFET and IGBT, internal insulated gate bipolar transistor, we will just discuss their basics only. A power MOSFET has three terminal. Uh, Arrow indicates the direction of current flow. MOSFET is a voltage control device. This is the symbol of a MOSFET. Okay, this is the symbol of a MOSFET. Drain, source, and gate are three terminals, and the arrow shows the direction of current flow. And this is the biasing of a MOSFET. You can see that gate and source terminal are biased, and its drain voltage is also biased. So a MOSFET is voltage control device. The operation of MOSFET depends on the flow of majority carriers only. Okay. So next one is insulated gate bipolar transistor. IGBT has its input impedance properties like MOSFET, and its low on-state power losses like a BJT. So this transistor has some properties like MOSFETs and some properties like a BJT. What are IGBT characteristics? Here are controlling parameters: gate emitter voltage, as IGBT is a voltage control device just like a MOSFET. When VGE gate emitter voltage is less than VGET, what is VGET? VGET is gate emitter threshold. When VGE is less than its threshold value, IGBT will be in off state. So these are the VI characteristics of a IGBT. VCE is the collector to emitter voltage. VGE, these lines are for different VGE, increasing VGE, and this is the current. So these are the VI characteristics of a IGBT. Okay, next is basically this is a table characteristics and symbols of power devices. We have discussed some power, a lot of power electronic devices in this chapter. So he has summarized basically all devices in one table. So a diode has this symbol and this VA characteristics. Similarly, a thyristor has this symbol and these VA characteristics. A gate turnoff has this symbol, a triac has this symbol and these characteristics. Light activative SCR has this symbol. These symbols are for light. It is activated by light at the gate. Okay, NPN BJT has this symbol and this characteristics. PNP BJT has this symbol and this characteristics. N-channel MOSFET, N-channel MOSFET has this symbol and these characteristics, and P-channel MOSFET has this symbol and these characteristics. So basically, we have summarized all the devices in one table. Next table is basically this is a table, some application of power electronics. You can see these are the various application fields of power electronics. One thing you can notice that he has written all the application in alphabetic order. A, B, and C, and all the applications are in alphabetic order. Well, in the past, I have used this table for assignments. I can give different assignments to different students. Like I can assign, let's say, application of power electronics in air conditioning to one student, application of power electronics in audio amplifiers, application of power electronics in chemical processing, similarly application of power electronics in other, let's say, oil well drilling, application of power electronics in solid state contractors or solid state solar power supplies. So I can use this table in assigning assignment number 1 or maybe later. So you can see these application of power electronics. And the last page is basically the review question of our textbook. We are using this textbook, Power Electronics. Power Electronics by M.H. Rashid, Circuit Devices and Applications. This is the name of the book, and this is the name of the author. And this is chapter number 1, Introduction, and these are the review questions of chapter number 1. Okay, so we will discuss these questions in our online lecture. What is power electronics and what is thyristors commutation and force commutation, line commutation, and what is thyristor and triac and GTO. Uh, these questions you can skip. Basically, we have not discussed the principle of AC to DC or AC to AC or DC to DC conversion. We will discuss these 4 topics in detail. Basically, you can say we have full chapters of these 4 questions coming in next weeks. So we have not discussed these 4 questions in this chapter because there are separate chapters for these questions. So you can skip these questions and you can cover all those questions which are discussed in our previous lectures. What is a converter? What is turn off time? Okay, so these are the questions which we can discuss in our online lecture. Okay, thank you. This is the end of our lecture number 2, and we can further elaborate our lecture in our online session. Thank you.